Assalamualaikum warahmatullahi wabarakatuh. This time we are going to do some operation on a particular matrix that we call elementary row operation, or simply ERO. E for elementary, R for row, and E for operation, elementary row operation. Okay, we are going to use this operation to produce one particular type of matrix that is in the form of a reduced row echelon form. Okay, or the short form of it is RREF. Okay, R for reduce, the second R for row, E for echelon, and F for form. Reduce row echelon form. Therefore, in this video, we are going to discuss these two very important concepts. Number one is we want to talk about ERO, what is actually we mean by elementary row operations, how many of them altogether, and how to do it. We are going to discuss that shortly. And then after that, okay, by doing ERO, we are going, or we are trying to fulfill the requirement of RREF matrix. Okay, and what are the requirement for RREF? Okay, that we have to follow. Okay, that also we are going to discuss in this video. Okay, now for the first operation in ERO is this one, that is we can always interchange. We can interchange between any two rows. Okay, that is, this is our row number one, right? And this is for row number two. This way. This way. This is row number two. Now, between row one and row two, we can always interchange their position. Okay, we are talking about rows here. We can interchange between rows, not column. Okay, we are going to use elementary row operation, row, not column, right? So we can interchange between row number one and row number two. We write like this. Okay, having an arrow that is in both direction. R1 change to R2 and R2 change to R1. Therefore, if we do that, the matrix will become like this: 2, 5. The second row becomes the first row, and the first row becomes the second row. That is, 3, 1 will be the second row. This is the new matrix after we interchange between row number 1 and row number 2. All right, let's continue for the 3 by 3 matrix over here. So now, for example, in this matrix, we are interested to know how the matrix look like when we interchange between row 2 and row 3. See what happened. We interchange between R2 and R3. Okay, meaning to say row number 1 is still the same. Okay, it's still the same. Okay, still stay in the same row for row number 1. So we have 1, 4 and -3 for row number 1. Now between row 2 and row 3, change position. Row number 3 now become row number 2. So we have 0, we have 1 here and 1 there. And for row number 2 now becomes row number 3. We have 0, 0 and 2. Alright, so what we are trying to show here, in elementary row operation, we can always interchange between any two rows. Okay, that's the first operation in elementary row operation in our ERO. Now let's see, for the second operation that we can do in our ERO is that we can always, okay, it is allowed to multiply a row by any number except 0. Okay, we can multiply any row by any number except 0. For example, for this 2 by 2 matrix, this is matrix 2 by 2, we want to multiply row number 2, for example, okay, by row number 2 by 2. We want to multiply row 2, we want to multiply it by 2. And we want to write it down in row number 2, of course, and see what happened. Okay, row number 1, we are not doing anything with it, so it stay the same. So we have still 2 0 in row number 1. Now for row number 2, since we multiply row number 2 by 2, so all element in row number 2 now will change, okay, will double, because we multiply by 2. So 2 times 3 will be 6, and 4 multiplied by 2, we have 8. 8 there. So this is our new matrix after we multiply row number 2 by number 2. Okay, so we have 2 0 and 6 8. Now for this matrix, okay, let's do this. Row number 3, we want to multiply it by, for example, negative 3, and let's do that and write down the answer, of course, in row number 3 and see what happened. Row number 1 is still the same, haven't changed because we didn't do anything with it. 2 1 and negative 3 there. We have row number 2 also still the same, 5, we have negative 4 and 1. But for row number 3, we have to multiply by negative 3. So all numbers in row number 3 will change. So 3 times negative 3 is negative 9, the first number. 0 times negative 3 is still 0. We have 0 there. Negative 3 times 1 is negative 3. Okay, this is the new matrix. Okay, after we multiply row 3 by negative 3, that's what we get. Alright, that is the second operation in elementary row operation. That is multiply a row by any number except 0. We are not allowed to multiply a row by 0. It's not allowed. Okay, other number can, but not 0. Now let's see the third operation that we can do in elementary row operation is this one. That is, we can add element of a row, okay, to corresponding element of another row. Meaning to say, we can add 2 rows together, but we have to add the element accordingly. If it is position 1 1, we have to add with position 2 1, for example. Now for this matrix 2 by 2, what we want to do is we want to add row number 1, we want to add it to row number 2, and we want to write down the answer in row number 2, for example, and see what happened. Okay, now row number 2 will change, but row number 1 is still the same. So we have to write down row number 1, 1 and 2. Now for row number 2, the new row will be just the sum of row 1 and row 2. So 1 plus negative 1 is 0. 2 plus negative 1 is 2 minus 1 is 1. Okay, that will be the new matrix for this matrix after we add row number 1 and row number 2 together. So we have 1 2 and 0 1. Now for this matrix, what we want to do is we want to add row number 2, we want to add it with row number 3, and we want to write down the answer in row number 3 and see what happened. Yeah, see what happened here. All right, for row number 1, it's still the same. That is 1. We have 7 and negative 3 there. For row number 2, also still the same. 2, we have 1. We have 1 there. Now for row number 3, actually will be the sum of row number 2 and row number 3. So 2 plus negative 2 is, we have 0 here. 1 plus 4 is equal to 5, and 1 plus 1 is equal to 2. Okay, that will be the result of the new matrix after we add row number 2 and row number 3. Okay, and we write down the answer in row number 3. Okay, this is the new matrix. Yeah. Okay, let's see. If we combine operation or step number 2 and step number 3 together, namely if we multiply a row by a number, okay, again multiply a row by a number and then add the new row to another row. Okay, first we multiply a row by a number and then we add it to another row. Okay, it is allowed to do that. We combine step number 2 and step number 3 together. Step number 2 says that we multiply, okay, a row by a number. Step number 3 says that we can add any two rows, right? So if we combine step number 2 and step number 3 together, okay, what will happen is we are going to multiply a row by a number and then we add it to another row. Okay, for example, let's see if we do for this 2 by 2 matrix, we want to multiply 2 multiplied by row number 2 and then we are going to add with 2 times row number 1. What I mean is row number 1 here, 2 multiplied by row number 1 and we want to add it with row number 2 and we want to write the answer in row number 2. Okay, let's see what we get. Again, row number 1 still the same, that is 1 and 1 there. For row number 2, we have to multiply by 2, okay, and then row number 1 we have to multiply by 2 and then we have to add it with row number 2. So what will happen? We have multiplied 2 by 1 will be 2 here. 2 multiplied by 1 also we have 2 and then we have to add with row number 2. So 2 plus negative 2 is 0. 2, okay, 2 plus 4 is 6. Yes, this is what we get after we multiply row number 1 by 2 and then we add it to row number 2. So that would be the result. That is 1106. Now suppose that for this matrix 3 by 3, what we want to do is we want to multiply like this. We want to multiply 6 multiplied by row number 1 and then we want to add with row number 3 and we are going to write the answer in row number 3 and see what happened to this matrix, right? So we are going to write the answer over here. Now for row number 2 and row number 1, it will not change. It's still the same row, you know. So we have 1, we have 0 and we have negative 3. For row number 2 is still the same also. We have 2, we have 1 and we have 1. The only change is on row number 3. Okay, now the operation is 6 multiplied by row number 1. Okay, maybe we can write it down. Here we have 6. 6 times 1 is 6. 6 times 0 is still 0. 6 times negative 3 is negative 18. Okay, these new numbers here, 6, 0 and negative 18, we are going to add it to row number 3 accordingly, correspondingly. Alright, so 6 plus negative 6 is 0. 0 plus 5 is 5. Negative 18 plus 1 is negative 17. Yes, this is the new matrix that we have. After we multiply row number 1 by 6 and we add it to row number 3. Okay, and we write the answer in row number 3. This will be the answer. That is 1, 0, negative 3, 2, 1, 1 and 0, 5, negative 17. Okay, that is combining step number 2 and step number 3 together. Okay, please take note that what we have done here is that we multiply a row by a number, first, and then we add it to another row. Okay, that's the operation. Very important to write down the operation clearly, like what we did here. This is the operation. Okay, usually we write the operation above the arrow, like this one also. Okay, write the operation above this arrow. This is the arrow. Write the operation above the arrow. Okay, yeah, that's all. I mean, the operation that we can do in elementary row operation, ERO, is these three operation. Okay, operation number 1, operation number 2, and operation number 3. Again, operation number 1 is just exchange any two rows. Operation number 2, you can multiply any row by any number except 0. Alright, and operation number 3 is we can always add two rows together. Or we can combine, like in this example here, we can combine step number 2 and step number 3 together. That is, we multiply, okay, the row by a number first, and then we add it to another row. Okay, we can do that. It's allowed. It's okay. Okay. Now, let's see the requirement for RREF. Because the purpose of our doing all this operation is we want to fill, okay, we want to fulfill the requirement for reduce row echelon form matrix. Okay, now the question is, what is the requirement for RREF? Okay, this is the first one. That is, all 0 row, if we have, all 0 row must be written at the bottom of the matrix. Yes, this is the first condition for RREF. That is, if that matrix having a 0 row, that 0 row must be written at the bottom of the matrix. Now, I hope you understand what we mean by 0 row. Okay, 0 row. 0 row means a row having all 0 elements in that particular row. Like in this example here, in this example, you see, for row number 1, we have all 0, right? Yes. Therefore, row number 1 is a 0 row. Now, to fulfill the requirement for reduced row echelon form, okay, we have to move this 0 row to the bottom of the matrix. So what we have to do, we have to exchange. We have to use the first operation in elementary row operation, that is exchange between two rows, you know. So what we have to do is we have to exchange between row 1 and row 2. Okay, so what will happen is we are going to have a new matrix. Now 0 row will be at the bottom, 0 0 0 0 0 0 there, and then we have negative 2 and negative 2 and 4. Now this matrix, this new matrix, fulfill this particular requirement. Requirement number 1, that is 0 row must be written at the bottom of the matrix, right? You see here, this 0 row now at the bottom of the matrix. Okay, fulfill the first requirement. Good. Okay, good enough for this. Okay, now for this second example, please notice that we also have 0 row in this matrix. That is in row number 2. This is a 0 row, right? Yes. Now, if this 0 row at this position, it does not fulfill the requirement for RREF. So we have to do something. Can you tell me what we have to do in order for us to fulfill the requirement, this particular requirement, that is 0 row must be at the bottom of the matrix, right? So what should we do here? Yes, we have to exchange between rows. So row number 2, we are going to exchange between row number 2 and row number 3. Okay, now if we do that, what happen is we are going to have this new matrix. That is still the same for row number 1 because we didn't do anything to it. So we have 1, negative 2, negative 3. Now row number 3 becomes row number 2. So we have 4, we have 2 and 1. Now this 0 row becomes row number 3. 0, 0, 0 like this. See here? See here? The 0 row now is at the bottom of the matrix. Therefore, this matrix fulfill this first requirement for RREF. That is, all 0 row must be written at the bottom of the matrix. Okay, that's the first requirement. Now, the second requirement for RREF is this one. That is, for a row that is not all 0, the first non-zero element must be 1. Okay, maybe we can read this statement twice so that we can understand what the statement means. For a row that is not all 0, meaning it is not a 0 row, okay, for that particular row, the first non-zero element must be 1. And this number 1 is called leading 1. Okay, they have a special name for it. Leading 1. We call it leading 1. Okay, now, for example, like in this matrix 2 by 2, we have 1, 3, and 0, 4. Okay, this number 1 is the leading 1 for the first row. This one is leading 1 for the first row, right? Now, for row number 2, we don't have leading 1. You know why? Because the first number after 0 is not 1. This is not a leading 1, right? Because we have number 4, we don't have 1. This is not a leading 1. So what we have to do is we have to, to do operation so that this number 4, becomes 1. So how to do that? We can use ERO again. So we have to multiply something, right? So we have to multiply 1 over 4 multiplied by row number 2 and write it down in row number 2. Okay, so that we have 1 at row number 2. So what we have is, for row number 1 is still the same. We have 1, 3. Now for row number 2, 1 over 4 times 0 is still 0. Now 4 divided by 4 is equal to 1. Now let's see, okay, whether this matrix having leading 1 or not for the second row especially. Okay, for the first row, we have leading 1. Yes. Okay. Now for the second row, the first number after 0 is also 1 now, right? Therefore, this matrix, okay, fulfill this requirement. That is, for a row that is not all 0, the first non-zero element must be 1. They have a leading 1. So now this matrix is acceptable, fulfill this requirement. Now let's see for the second matrix. For the first row, we have leading 1. It's good. But for the second row, we don't have leading 1. After this 0, we have negative 3. What we have to do is we have to change from negative 3 to 1. Now for the third row, after this 0, we have number 10. Yes, this number 10 also we have to convert to 1. So what we do is that, okay, this number 3, negative 3, we have to change it to 1. This number 10 also we have to convert it to change it to 1. So what we have to do is, for row number 2, we have to multiply by negative 1 over 3, multiply by row number 2, and write it down, the answer in row number 2. Okay, for row number 3, what we have to do is 1 over 10 multiply by row number 3 and write it at row number 3. Okay, you see, we are doing 2 operations simultaneously, right? Okay, that's why we have one operation at the top over here and another operation at the bottom. We are going to, to save some time or some space in terms of writing, So now we are ready to write down the final matrix. For row number 1 is still the same because row number 1 is good enough. It have already the leading 1. We have 1, 2, negative 3 there for row number 1. Now for row number 2, we have to multiply by negative 1 over 3. Multiplied by 0 is still 0. Negative 3 multiplied by negative 1 over 3 is 1. And 6 divided by negative 3, we have negative 2. I hope you understand why we get negative 2, yeah? Now, for row number 3, 0 divided by 10 is still 0. 0 divided by 10 is still 0, and 10 divided by 10 is 1. Now let's check whether all these rows, they have leading 1. For row number 1, yes, we have leading 1, this number. Row number 2, we have leading 1, this number. And for row number 3, we have also leading 1, that is this number. Therefore, this new matrix fulfill this requirement for RREF. That is, any non-zero row, they have leading 1. Okay. Now, that's the second requirement. Now, the third requirement is this. That is, while moving down the rows, the leading one must move progressively to the right. The leading one must move progressively to the right. For example, like the first matrix here, this is the leading one for the first row. This is the leading one for the second row. You see here, when we move down the row, okay, the second row, the leading one is progressively to the right of the first leading one. Okay, I hope you understand what we mean. Okay, as we go down the row, the leading one must move progressively to the right. Now, for the second matrix here, let's check whether we have the leading one is progressively to the right. Okay, the leading one for the first row is this one. The leading one for the second row is this number. And the leading one for the third row is this number. Okay, you see the position of leading one for these rows, they are not progressively to the right. We have to make some adjustment here, move the rows around, see what happened. All right, so what we have to do is we have to move the third row to become the first row. So we have 1, 1 and 4, like this. The last row now become the first row. That is, the third row become the first row. So that we have our leading one, okay, to the left, to the most left, all right, of the matrix. Now, which one or which row will be the second row? Which one is the best one? Which one is the correct row to be the second row? Of course, this one, right? This one. So we move it around, it's become the second row. So we have 0, 0, we have 1, we have -3 there. Okay, and then the second row become the last row. So we have 0, we have 0, and we have 1. Now let's check the leading one. This is the leading one for row number 1, good. The leading one for row number 2, progressively to the right, good enough. The leading one for row number 3 is over here, also progressively to the right. Therefore, this particular matrix, okay, fulfill the requirement number 3. That is, the leading one must move progressively to the right. I hope you understand what we mean by progressively move to the right. Okay, right. Those are three conditions to be in reduced row echelon form. This is the last condition, the last requirement to be in reduced row echelon form. That is, the numbers above and below the leading one must be all zeros. Meaning to say, for example, for the first matrix over here, this is the leading one. This is the leading one for row number 1. Below this number must be 0, right? Yes. But for this particular matrix, that number 4 is not the leading one. So what we have to do is, we have to make this as our leading one. Let's see. So what we have, the operation is that we have to divide here 1/4 multiplied by row number 2 and write it in row number 2. So what we have is row number 1 is still the same, 1 and 3. Now for row number 2 we have 0. 4 divided by 4 is equal to 1. Okay, this is the new matrix. Okay, and the leading one is this for row number 1, and the leading one for row number 2 is this number 1. But for this condition, okay, it says that this leading one above it must be 0. That is, this number 3 here must be converted to 0. We have to change this number to 0. So how to do that? This is the operation. Okay, we have to use elementary row operation to do that. That is, we have to add, that is row number 1, we have to multiply row number 2 by negative 1. So we have R1 minus R1 and multiply by 3. So R1 minus 3 R2 and write the answer in row number 1. Okay, R1, okay, minus 3 row 2, and then we write the answer in row number 1. So what will happen is that, okay, we are going to have this. Row number 2 is still the same, that is 0 and 1. Now for row number 1, okay, this is still 1. Okay, when we multiply row number 2 by negative 3, we have negative 3, and when we add it to row number 1, we have 0. Okay, so this will be the answer. Okay, the new matrix, that is 1, 0 and 0, 1. Now let's check it again whether this matrix fulfill this requirement, that is above and below leading one must be 0. Leading one for row number 1 is this, below it 0. Yes, good, this good enough. Now leading one for row number 2 is this one, and above it the number is 0. So that's one also good. So this fulfill the requirement. Let's see, for matrix number 2 we have 1, 2, 2, 0, 1, 1 and 0, 0, 1, and see the leading one for row number 1 is this. Below it 0. All this number 0. Good enough for leading one in row number 1. For row number 2, leading one is this number 1, but above it is not 0. Therefore, we have to do something with it. Okay, that is do elementary row operation so that this number 2 here, this number 2 becomes 0. Now, for row number 3, the leading one is this 0. I mean this one. Above it, we have this one, we have this number 2 are all not zeros yet. So we have to do something, right? Alright, so for this matrix, what we have to do is, okay, let's change this number first to 0. Okay, how to make it this number 0? So what we have to do is we have to add, that is row number 1 minus 2 multiplied by row number 2, and we write down the answer in row number 1 and see what happened. Okay, row number 2 is still the same, that is 0, 1, 1. Row number 3 also still the same, that is 0, 0, 1. Okay, the ones that change is row number 1 only, so we have 1 there. 2 minus 2 is 0. 2 minus 2 is also 0 there. Okay, that's the new matrix. Okay, now let's check one more time whether this matrix having all zeros above and below leading one. Now for first row we have this leading one, below it are all zeros. For the second row, this is the leading one, above it 0 and below it also 0. Good enough. This is good. This is good. But for the leading one in the third row, that is this number, above it, this one good, 0 already, but this one we have to do one more step, okay, to make it 0. Alright, so let's do that. Let's do that. Okay, so what we have to do is, we have to row number 2 minus row number 3 and write down the answer in row number 2. Okay, let's see what will be our final answer. Row number 1 is still the same, 1, 0, 0. Row number 3 also still the same, 0, 0, 1. Now for row number 2, when we subtract row number 2 minus row number 3, we have 0 there. 0 minus 0 is 0. 1 minus 0 is still 1. 1 minus 1 is 0. Therefore, this is the new matrix. See, the leading one for this one are all zeros below it. The leading one for row number 2 is this one. Above it and below it are all zeros. Leading one for row number 3 is this number 1, and above it are all zeros. So this matrix already fulfills this requirement. Okay. Now for exercise, maybe we can do this exercise now and see whether we can identify whether the matrix given already in RREF or not. Okay. Now for the first matrix, you see this is the leading one for row number 1, but below it, okay, below this number, this is not 0, so therefore this is not RREF yet. The leading one for this matrix 1 is 0, okay, below is 0. The leading one for row number 2 is this number 1, and above it 0, so this one is okay, good. Leading one for the first row is this, below it 0, this one is good. But for the second row we don't have leading one, so therefore this is not in RREF yet. For this matrix, this is the leading one, and below it 0, good. And we have a 0 row, and we write 0 row at the bottom of the matrix. This is good. Now for 3 by 3 matrix, leading one here, leading one here, below it are all zeros, okay. Now for this leading one, above it 0, and below it also 0, and the 0 row is at the bottom. Therefore this matrix is good. Leading one is this one, below it 0. Leading one for the second row is this number 1, above it 0, and below it 0 also good. Now the leading one for the third row is this one, above it, oh, this one is not 0, this one is not 0, therefore this is not in RREF yet. Now the leading one for this row, that is this one, leading one, the number below it are all zeros, good, and all zeros are written at the bottom of the matrix, so this is in RREF form, reduce row echelon form. Okay, now there are some exercise here. I want to leave it for you to think about it. Okay, exercises. The question is, are the following matrices already in RREF? Reduce row echelon form or not yet? Okay, we have A, B, C, D, E, F, and G. Okay. All right. Now I think that's all for this video. We see you next time discussing different aspect of matrices. Okay, that's all for now. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.